In 2012, Superstorm Sandy hit the Northeast and caused millions of people to lose their homes, possessions, and power. Naturally, at this time, people were trying to notify their loved ones about their well-being. Unfortunately, this created a very high amount of network traffic, as phone calls and text messages were trying to be sent at the same time. Because of this high amount of network traffic, many of these phone calls were not completed, and many of these text messages remained unsent for a period of time. The senior team of Ryan Marren, Peter Wu, Chris Lovrin, Zack Reiter, Max Kaplan, and Keith Carreon have decided to create an application that would facilitate the communication between people during times of need. Our application, EmergEnsure, would address the problem of periods of high network traffic with the use of statistical multiplexing. Statistical multiplexing is a concept that relies on the fact that network traffic is bursty and that most of the time the consumer is not using the bandwidth. Because of this, a network provider does not need to build infrastructure that is able to serve all of its customers at once while guaranteeing the bandwidth they are paying for. It is a common occurrence that during natural disasters, terrorist attacks, and other sudden call events, that network traffic is very high and many actions cannot be completed. It is during times like these when our application will prove to be very useful. Our application will mainly use SMS, or short message service, as its medium of communication. Why SMS? SMS is a way to send a message while minimizing the network resources used. The data sent using this SMS will also be compressed in order to fit as much information as possible into the character limit. After the data is compressed and sent, it enters as nodes within a number of queues into the prioritization system for the application. Depending on certain criteria, the nodes may be moved up or down in the queue to be sent. For example, a person who is in need of urgent help will be moved to the top of the queue, while a person who is okay will be moved down. This allows us to help people who are in dire need first. The nodes will also contain several variables, including urgency, name, date, time, GPS coordinates, and a short comment section. The GPS location can be estimated or manually entered by the user. The application will then try and send an SMS. If this fails, it will resort to other channels of communication, but the SMS channel is optimal. This application is targeting anyone and everyone. This application is more proactive because it is probably impossible to download the app during a natural disaster. People would download the application in advance in anticipation of an event in which communication is critical but not necessarily doable. This application will hopefully make more urgent communication easier by minimizing data transfer. Thank you.